So today I'm going to be showing you how centrifugal force affects another object and how centripetal force and inertia can cause one thing to move another. Now here I have two centrifugal force machines, or pretty much two giant two-sided fidget spinners, depending on how you want to look at it. But as you see, if I spin the small one around, which happens to be not really heavier, but because it's halfway, and I'm going to be spinning it more than twice as fast, it should make the red one accelerate at a certain rate. I'm not sure what type of rate. I don't know the math behind that, but I'm going to show you anyway. See how it's moving? That's either the wobbling or it working. But when I stop this and make the bigger one, which happens to have more weight and is about twice the length, but if I have like half the speed of the bottom one, I should make it speed up. But if I have it more, they should eventually start to come together, one accelerating and then stopping at the same place, right? So I'm going to test that out. And as you can see, it starts accelerating almost instantly. And both of them are starting to slow down. But as you can see, they're becoming close to parallel. But this one is slightly moving faster, or at least accelerating, than that one. It was here before in like a second, and then here. And that's acceleration. But if I take the bottom one out, just put in the top one, and then I take the caps off, dang it. This might be taking a while, but switch that up. Take the end cap. And then, to show how centrifugal force moves an object, because centrifugal force, it's an illusion, remember that. It's a mix between inertia and centripetal force, which is a net force that happens to make an object move in a circular path if it is being moved by a circular path. And I'm going to start off at in the middle, and then I'm going to spin it as fast as I can and see what happens. See, they almost instantly hit the outside. And that is centrifugal force. And I noticed something about centrifugal force. The faster something is moving closer to the outside will be moving, will have an apparent weight of faster than the inside, causing an imbalance in mass, gravity, all that jazz. And if you were to spin this at as fast as the speed of light, just say that hypothetical, or at least near the speed of light, had really big ones, like really big of these, spin them around at near speed of light speeds, just pretend this is the speed of light, you will have yourself a black hole. And the reason that is because when something has centrifugal force, not only is it spinning around, but it's also moving itself outside. So to do that, it must have a force. And I don't know much about physics, but I can still explain this. But I'm pretty sure that it'll increase its apparent weight by a certain amount. And if it went fast enough, and if it was heavy enough, say the speed of light, that speed again, it would cause a black hole. And if you were to make that travel at the speed of light, you would be able to suck yourself in at the speed of light, traveling at the speed of light, therefore causing you to multiply the speed of light by the speed of light, because you'll be sucking in at the speed of light as fast as the speed of light. Well, technically the speed of light will still be faster than you, but you get the idea. But to show one last time that centrifugal force does exist, even though it's actually a mix between inertia and centripetal force, I'm going to start spinning these. Is this horizontally or vertically? And I think it's vertically, but I'm going to start spinning it. Watch. See? That sudden acceleration caused it to fall out. And that just proves how inertia and centripetal force can work together to cause centrifugal force. But remember, it's just an illusion. So, remember that. And that was the lesson for today. And stuff again, because